So the problem that we have with any tunnel traffic is obviously it's encrypted from the machine to the machine. And if we have any firewalls or gateways or intrusion detection systems along the way, then we will not be able to look inside the data packets at all and examine them for any threats. So the way that this is avoided is that we can set up a proxy. In this case, Bob doesn't communicate directly with the server. Bob will only be allowed to communicate with a proxy. And we create what's called the dual-homed architecture, where we have a firewall here and a firewall here. This firewall will only allow a connection to the proxy and no other connections. So all other connections will be barred here unless they go to the proxy. This firewall here will only accept connections from the proxy and no other machine to a destination. In this way, we isolate the tunnels and we go through the proxy. The proxy typically focuses on a certain protocol such as web or FTP, and will examine and can examine all of the traffic that comes in. Obviously it can be a bottleneck and can slow things down, but from a security point of view, we can actually go through all of the traffic and reject anything that isn't quite right. We can also log all the requests for accounting or for other purposes. So the proxy is useful in breaking this encryption tunnel and making sure that we can check the traffic that's coming in and coming out. Another device that we often use these days is what's called a web application firewall. With this will sit outside of the corporate network, such as a service that's run by Cloudflare, and will break the tunnel again, just like the proxy, so that the user thinks they're connecting to the remote website, but actually they're connecting to the WAF. In this case, the encryption tunnel is created between the WAF and the client, and then we decrypt the traffic. We can then examine all of the details, examine if it's a bot, and look at any filtering that we have. Maybe we block certain IP addresses, we block certain bots from our network, and this will drop traffic here and also log them. Typical things that we might do is looking at the HTTP requests string, different network addresses, and so on. Even we can geolocate, we can stop certain regions of the world having access to our services. The certificate actually comes from the WAF, it's not from here, and the DNS also is dealt with from the WAF. So it's not the IP address of the server that is sent to the client. It will be the IP address of whichever WAF is going to be used. And we can obviously load balance here. We can have multiple WAFs, and then the DNS will map it to one that's hopefully free or as near as the user as possible. In this way, we can actually balance the traffic, so the traffic will be filtered as we go through. So then, once it's filtered, it can be sent to the server, and obviously this firewall here would only allow the connections from these WAF IP addresses. So no other IP addresses will be allowed to connect to this server here. So Bob can't just connect to the server directly. He needs to go through the WAF in there and get all the traffic checked. Okay, so in this way we can actually integrate intrusion detection systems and filtering and so on.